Hello and welcome to my workshop. So today we're going to be starting on a new project, and we're starting off with putting together this VS410, and then we're going to get on to making a 1968 Ford F250. Alright, so let's get started. So I've been wanting a Vanquish VS410 for some time now. I wasn't sure about them when they first came out, but after working on the LS Mail Jeep, I was sure that I needed one. I can't say I'm a big unboxing video fan, but I can say this truck is packaged well. I really like how the bags are clearly labeled and separated with some logic, instead of just lumped together like some other kits. It has been a little while since I put a kit together, and I'd forgotten just how much fun it can be. Not only did you get the satisfaction of building it, you get a familiarity with the chassis and the running gear. I try to keep each step isolated and do my best to clean between each one. It's so easy to get lost if you don't have a well-organized system. If there are a large number of parts, I will sometimes knoll. Knolling is a technique to organize like parts before starting the assembly process. I'm applying a small amount of grease into the bearings as I assemble them. I do the same for the gears. You really don't need a lot, but just the right amount of grease can make it work so much smoother. The clamping and heavy-duty mounts for the bearing and gear is a very nice touch. It might be a little overkill, but it's light years ahead of the old cases, which you could literally see flexing under load. I have to admit that there are very few manufacturers putting out subpar stuff these days, though. When you have a lot of metal parts, like in the VS410 or an RC four-wheel drive, Loctite is critical. I'm really surprised by how so many people skip this step. I would say that it's a guarantee that the screw will back out without Loctite. If you get an RTR and there are metal parts, the first thing you should do is take it apart and Loctite the screws. This is especially the case for RC four-wheel drive, since they seem to have an aversion to using Loctite at all. I wanted the electronics quality to match the chassis for this build. I decided on a Reefs RC Raw 500 servo. It is way more servo than a trail truck needs, but I really believe in their quality and their customer service is top notch. The VS410 chassis has a large mount for the front and rear. There are a number of items incorporated in these mounts. They also do a great job of locking the chassis together and preventing racking. Even though the mounts have very specific purposes, they are easily modified if needed. The front mount is set up to run a servo and a servo winch. I'm not positive I will even have a winch, but if I do, it will guarantee not to be a servo winch. I don't have any issue with people using them, but for me, they just don't make sense. To me, a winch is just used to assist the truck and not pull the truck completely up. To me, having a smaller winch gives more a realistic feel. For the most part, all you really need to do is just keep the front end pulled down, or just keep the truck from slipping. Unless I was just running a Lexan body on a beater trail truck, I never run stock sliders. For the most part, all of the stock sliders look toy-like to me. This is not the case with the VS410 though. There are two options for the sliders, but both are keyed into the structure which bolts up to the chassis. One option is made for a Lexan body and has a very innovative system for capturing the body. The other option, I assume, is for a hard body, but I guess could be used for either purpose. It's just a simple tapered shape and looks quite good. I ended up using the Lexan one on a separate build and the tapered one on this build. When I worked on the LS Mail Jeep, I didn't take apart the transmission, so I wasn't quite sure of the setup. After seeing this design, I am even more impressed with this truck. The bearings are mounted in a way to make sure proper alignment and to prevent deflection. This is critical for bearing surfaces, since surprisingly a small amount of force can cause binding. The ESC and motor are from Hobbywing, and they are the updated FOC system. I have an early version of this system, and I really love it. I do think there are better, more powerful systems on the market. Some might have better software for, say, like hill hold or braking. But the Hobbywing system is just a great overall ESC and motor combo. Being a combo is where its strengths shine. Both components work so well together and offer a very smooth and enjoyable experience. The FOC system takes a little bit to get used to, but once you do, you will not want to drive another system. For me, the best thing is the ability to have an ultra smooth and controlled descent down a steep terrain. Another great benefit of this transmission is how low slung the motor is. You're able to get the motor and transmission way down in the chassis, which opens up so much space for an interior. The rear axle is pretty close to the front in assembly. There are obvious differences, but the majority are the same. Just pay attention to make sure you're getting these things in correct place and using the proper length screws. With the transmission and chassis mounts installed, it's time to get to the links. Vanquish uses some very beefy links, and they're tapered nicely to keep the truck sliding over the rocks. I thought very hard about how I wanted to deal with the links, since the F250 is a very long truck. I'm building a short wheelbase truck, but even with that, I would have to extend the rear axle to get it to fit. I really wanted to keep the stock Vanquish length, so I modified the bed to accommodate the wheelbase. This meant taking a small amount out of the bed before and after the wheel arches. I had to modify the front geometry on the LS Mail Jeep, but luckily I didn't have any issue on this body. There was plenty of room. The shocks, which are incision, are nicely built. The system for capturing the spring is simple to set up, and they seem to be fairly smooth. Not sure how well they will do long term as far as leaking goes, but time will tell. I bought a scale engine off eBay to go with this project. The servo and eventually the ESC will go pretty much dead center in the engine bay. I knew I couldn't use an engine which mounts over the motor since it's nowhere near the front. Even if I could, it would need to be highly modified. This engine is designed so that a fan sucks air into the intake filter and blows it straight down. The best part is the bottom half bolts on, so if you don't install it, the engine is pretty much flat on the bottom. Now eventually I will replace this engine with one I designed and 3D printed, but I used the design from this to carry through to the new engine. I needed to do this since the engine was just too small. It's a true 1/10 scale, but this truck is a 1.89 scale. I suppose the vendor doesn't know or realize that most, if not all, 1/10 scale trucks are really 1/9 scale. The 1/10 scale is really just a category and has not much to do with its actual size. I'm not overly familiar with this engine, but I heard someone call it a cammer. It's an older engine, and I think it'll fit really well with this build. I'm using G-made steel wheels and custom 3D printed hubcaps. The hubcaps are painted silver, and then the details painted in with black paint by hand. It's tough getting these details crisp, but with a 2.5 magnifier, it is possible. Another thing to help is a toothpick instead of a paintbrush. I would like to find a hard-tipped pick that would be suitable for this, but until then I would just keep using these toothpicks. As mentioned, there's a spot next to the steering servo for a servo winch. What I did was mount a piece of plastic in place that then affixed the ESC to it. This is a good spot since it's out of the way, high up, way away from water, and not far from the motor. The Hobbywing ESC combos are nice, but their proprietary plug makes it difficult if your ESC needs to be further away than the small amount they give you. You can get extensions, but I prefer not to if I can help it. With the ESC firmly in place, I cut the motor wires to length and solder them on. So I chose some RC 4-wheel drive BF Goodrents Mud Terrain TA tires to go on the G-made wheels. The tire and wheel combo are just perfect for a late 60s era truck. I had never used the G-made wheels before, but I would not hesitate to get more in the future. With the mechanicals pretty well sorted, I needed to turn my attention to making the body. This will be accomplished by using vacuum molds, scratch building, and some select 3D prints. I recently purchased a replacement sander and was very happy with how quickly it cuts through the MDF. Another benefit of this new sander is the large platen. Now I can get long pieces on there in one go instead of having to move back and forth trying to fit it all on. I'm always learning new ways to improve mold making. The thing I focus on the most is reducing the amount of sanding required. It is a messy and by nature not near as accurate as other methods. To achieve the iconic bump side, a 3D print file was created and then glued into place on the mold. This allows me to get a very accurate piece that would be near impossible by hand. Plus it reduced the time required by several hours. Another method I like to use is adding styrene pieces for areas which are bumped out or recessed. I guess it kind of depends on how you're looking at it, whether it's bumped out or recessed. And regardless, the lower part of the fender gets a chunk of styrene glued on and then sanded back to match. A little CA glue and filler will make quick work of the transitions. I use a similar technique for the area around the wheel arch. Styrene shapes, typically quarter round, are glued into place. Once the hot styrene is vacuum formed over the mold, it comes out looking like a small lip. It's much easier and more accurate than trying to add it on later. But this isn't always the case, as most of the time I add window trim later, but it really just depends. Another trick I have picked up is to make cuts at 90-degree angles into areas I need to remove material, such as the taillights. I can make a cut a few millimeters in, then switch sides and keep repeating until I have the depth needed. This also has the benefit of reducing dust, since I am removing most of the material by cutting and not grinding. So after the parts are vacuum molded and removed from the molds, the cleanup process begins. I try to cut back to the mold lines if possible, but sometimes it's easier to deal with trimming after it's removed. On the taillights, I mark what is needed to be removed with a pencil, then slowly grind away the plastic until it reaches that pencil line. As long as you go slow, don't push, and let the tool do the work, it generally makes a very neat line. With both bed sides ready, I need to turn my attention to the tailgate. At this point, special care is needed to make sure I'm both following the drawings, but also stepping back and making sure it looks correct. I needed really crisp lines that were deeply recessed. Instead of trying to carve it out, pieces of MDF were cut to the right thick shape and thickness, and then glued into place with CA. It's a little dangerous cutting these small pieces on the table saw, but I really pay attention, and when I'm doing this, I stand way out of the way. Once it is built up, some sanding is required to blend it out and get the final shape. The recess is capped off with a piece of styrene. I'm testing out the 3D printer to make pieces which can be glued into place on the molds. It worked out very well with the bump sides, so I decided to give it a try for the Ford lettering that is on the tailgate. It just took some careful measuring and the letters were glued into place. The taillights were also designed in Fusion 360. To make it easier for paint, they were designed in 3 pieces. There's an inner bucket where the LEDs will be placed. There's also an outer bezel which will eventually get chromed, and the lenses which are printed clear resin and then painted with a clear red. It just takes some careful trimming and grinding back to get the opening to match. Once I'm happy with the layout and I'm sure all the pieces will align properly, I start gluing everything into place. Where possible, I use solvent for the styrene to styrene joints. The solvent will not work on the resin, so I mostly use CA glue. It bonds really well, and with a little spray of accelerator, dries in seconds. Where possible, I attach inner structure pieces, such as the bed rail or tailgate inner panel, before the larger panels are all glued in place. This makes it easier for trimming and sanding. This is a very critical junction, and special care needs to be taken to make sure panels stay square. It is easy for the pieces to become a parallelogram at this point if not careful. If you don't have an inner structure, such as along the outside of the bed fenders, care must be taken that the panel remains flat. It is very easy to bow the panels due to applying clamping pressure. The end result makes it look like you slid into a tree and caved the panel in, which, if you're going for a beat up look, might be a plus. I was able to reuse a bed mold from a previous project, but I did need to make it a little larger. In general, I don't like to modify old molds. This case made sense though. All I needed to do to make it work was to add a material along the sides. This is not a problem for the original mold, since I had to trim back the edges anyway. I can still use it for an older project. I would just need to trim back a little further on the material this time. So this mold was mostly created due to the expense and time it takes to add in all the ribs commonly used in truck beds. In the past, I just took a flat sheet of styrene and glued thin styrene strips before lightly rounding over the edges with sandpaper. This works well, but it's time consuming and the strips are pretty expensive. Much like the side panel becoming stiffer due to the molded curves, this also allows for a stiffer bed while reducing the overall weight. Now, these models can add up in weight very quickly, so any reduction in weight is a good thing. So the inner fenders were made from a previous project where I built a 1951 F100. I didn't know it at the time, but the fenders in the F100 were from a later model truck. They did this due to having larger tires tucked underneath. This meant that I can get these fenders without having to make new molds, which is good. Once the measurements were taken and the fenders were glued into place, I cut things back to allow for room so the tires would have clearance. The last step for getting the body mounted to the chassis is to cut out holes where the shocks will stick through. I really hate doing this and I would have preferred to leave it flat, but in order to have a good working shock, compromises have to be made. I know these will be covered up, but that will have to be worked out later on. Each truck is unique in how I mount the body. Most of the decisions are made around where the battery is located though. If I can create an access panel, I would mount the body permanently. In this case, the battery is going under the cab, so I can mount the bed down permanently and have the cab removable. This is accomplished with drilling screws into a thick plastic plate mounted between the shock towers. A final detail piece in the tailgate is added, and this phase of the project is complete. I still have so much more to go on this project. There is a lot to it, but I am looking forward to having it complete. Until then, we'll see you on the rocks.